Today, we will walk you through our Risk Assessment QGIS plugin. Risk assessments are the cornerstone of anticipatory action. They help organizations and governments identify, analyze, and evaluate potential threats and vulnerabilities. By understanding the risks they face, they can make better decisions, developing and triggering early actions. Creating a robust risk assessment is a complex process. It involves integrating multiple datasets on exposure, vulnerability, and coping capacity for specific hazards, and then running statistical and geospatial analyses on top of that. Our QGIS Risk Assessment Plugin is designed as a user-friendly interface that empowers practitioners and local actors to conduct and update their own risk assessments. First, we conduct a thorough screening to gather and evaluate all available datasets for the scenario of interest. Next, we work directly with local actors through workshops to co-create the indicator weighing, which reflects the importance of each indicator. Finally, the risk calculation itself is handled by our plugin. Now, with that overview complete, let's move on with testing the plugin. First, make sure that the Python pandas library is installed. To do so, open the Python console within QGIS. Type import pandas and press enter. If no error appears, you're good. Otherwise, install pandas using your command terminal. Just type in pip install pandas, just like you see on the screen. Now, let us show you how to install the plugin itself. Go to Plugins and click on Manage and Install Plugins in QGIS. In the Settings tab, enable Show Also Experimental Plugins. Then return to the Plugins listing, search for Risk Assessment, select it, and click Install Plugin. Once installed, close the dialog. The plugin is now active and ready to use. To launch the plugin, open the Processing Toolbox in QGIS. If you don't see the Processing Toolbox button, you can install it as a plugin, same as before. Assuming you have the Processing Toolbox plugin installed, scroll to the bottom or use the search bar to find HeiGIT Risk Assessment. Finally, double-click to open the Calculate Risk Assessment dialog. Now, let us show you an example on how to use the plugin using available geospatial data of Somalia. The plugin requires the following inputs: administrative boundaries, exposure, vulnerability, and coping capacity. Administrative boundaries are a polygon layer showing the geographic units of analysis, such as districts or regions in Somalia. This layer must include a column named ADM_P-code, containing the P-codes, and ADM_EN, containing the names of the administrative boundaries. You can load the file by clicking on the three dots on the right. Now, let's take a look at exposure, vulnerability, and coping capacity. For these, we need input indicator files that represent the three main dimensions for describing risk. Let's start with exposure. Like vulnerability and coping capacity, this is a .csv file with a mandatory column ADM_P-code. You can also add the column ADM_EN, but it is not mandatory here. In our Somalia example, the exposure indicator was created using multiple datasets. The vector file of the combined drought index by FAO SWALIM was combined with the world population raster file and the FAO livestock raster layer in order to describe the physical exposure to different historical drought classes. For vulnerability, normally most datasets are available on a local and especially a global level. The World Pop Sex and Age dataset is a great global baseline dataset for disaggregated population data independently of the hazard. In Somalia, we also included more context-specific vulnerability data, like conflict data from ACLED, such as the number of internally displaced people or land degradation information. Finally, coping capacity. This focuses on the ability of people, organizations, and systems to manage adverse conditions by using their available skills and resources. We included the number and accessibility of health facilities and schools per administrative unit, pulled from OpenStreetMap and calculated by Open Route Service. For the Somalia drought context, we also use the access to water sources and sanitation, datasets which are published by FAO SWALIM, which stands for Food and Agriculture Organization of the United Nations, and Somalia Water and Land Information Management, and from the UNFPA, the United Nations Population Fund. The weights file defines the importance of each indicator in the calculation. This .csv file must contain a column named variable_name with all the column names of the previous .csv files. It must also contain the columns category, weight, and direction. The category column indicates the category of the indicator, EXP for exposure, COP for coping capacity, and VUL for vulnerability. The weight determines the importance of each indicator. For each category, EXP, COP, and VUL, some of the weights must add up to 1. If this is not the case, the plugin will automatically normalize the weights in order to make the sum equal to 1 within each category, and a message will be printed. We'd like to refer to the documentation for the meaning of the direction value. If you do not have a prepared weight file, you can create one on the fly through the Weights Generator plugin, which is automatically installed when the Risk Assessment plugin is installed. Clicking on this icon opens a window where you can browse exposure, coping, and vulnerability indicators using the button on the right. Once selected, the indicators will appear in the table below. You can manually enter the weight and direction values in the corresponding rows. If you click the Default Weights button in the bottom right corner, each indicator will be assigned a weight value of 1. This means that no weighing is applied. All indicators are treated as equally important in the risk calculation. By clicking OK, you save the weight file locally as a .csv file. At the same time, it will appear as a layer in the QGIS Layers panel. With these dimensions prepared, exposure, vulnerability, coping capacity, and weights, we're finally ready to run the risk assessment. Our result is a vector layer that includes not only the scores of the different indicators and layers, but also an overall risk score and a risk rank for each administrative unit. By using the symbology options in QGIS, we can visualize the results for a nice map with just a few clicks. That's all for today. We hope that this explanation in our plugin helps you with your research. Feel free to reach out if you have any questions. You'll find the email address of our scientific contact in the description below.